Good afternoon. How's everyone doing? Anyone out there? Okay, good. My name is Rob Willis. I am a program manager in Windows Server and System Center Engineering in Redmond, although I actually live in Texas, and I was actually born and raised right about there, so I'm all sorts of confused. We're going to talk about automating System Center deployment using the PowerShell Deployment Toolkit, or PDT. PDT is a set of scripts and knowledge that we released to the TechEd gallery back in February of this year that's really all about automating full distributed deployments of System Center. So before we really get started, how many people in System Center 2012, before SP1, we had a feature called the Unified Installer? How many people tried or used the Unified Installer? Just show of hands. A couple. Okay. I was actually the PM for that feature in System Center 2012. A lot of what we learned through that process went into this set of scripts and knowledge that we released. This is not a product feature. This is community supported, freely available on the TechEd gallery, but it is really the natural progression of what was the Unified Installer. So I'm going to start with a few questions and just shout out the answers to these. How many products are there in System Center 2012, SP1? How many? 7? 8? 1. Man at the back. There is one. You can only buy one thing, System Center. It may have multiple components, but we actually promote, market, and sell System Center as one product. How long does it take to deploy that one product? Shout it out. A long time? 1 hour? You read the blurb for this session, didn't you? Typically, we get any kind of answer from 4 hours, a day, a week. If Microsoft Consulting's involved, maybe longer than that. I didn't just say that, did I? The answer is it takes too long. There's a lot of stuff. And what we find is a lot of our customers are using one or two components and aren't really taking advantage of all of the capabilities that we deliver in System Center because it's too complex, it just takes too long to get going. How many screens does an installation take? So including SQL, including all the prerequisites, clicking through all those setup screens, approximately how many screens do you think you go through to do that full installation of all those components of System Center? 50? 200? I actually lost count somewhere around 500. In Unified Installer, and Unified Installer delivered one very specific scenario that was just around single server deployments of each component for an evaluation type scenario. Unified Installer, there were 422. I did actually count those. I lost count somewhere around 500 with SP1 in the various different types of deployments we enable. How many post-setup integration tasks are there? What on earth is a post-setup integration task? Right. All those components in that one product, to really get the value from them, you need to understand how they all interact with each other. That's what I'm talking about in terms of post-setup integration. But what we find, a lot of our customers don't get to that, or it's too complex, or we've really hidden the fact that you need to do that somewhere deep in our documentation. Who's afraid of XML? It's okay. Okay. I will warn you, this session does involve manually editing XML, but my goal is, by the time I'm finished here, for you not to be afraid of the XML that's associated with PDT. You can't get it wrong. If you get something wrong, we block you from continuing. So it's really not too bad, and it's not creating, it is just editing. So I'm going to start with a demo. And the reason I start with a demo is because it actually takes a little while to complete, and I want to show what happens at the end by the time we get to the end. So I have 5 different environments I'm actually going to be demoing from here. I'm going to start with this first one, and this is, I'm not going to explain this yet, we'll go through it as we go through here, but this is essentially a full deployment of everything in System Center, all 7 components, with all the post-setup integration on multiple servers, so separate database servers, some things combined. It's essentially a fairly typical enterprise deployment of the entire System Center product. And so what you're going to see as we go through here, I'll skip back to the screen occasionally, you'll see various different states, but this is just showing the 7 different components starting and all the different roles in those components. We'll come back to that as we go through. The second one is actually a HA deployment. So let me just start this guy. Rather than all the components, this is a high available deployment. This has a SQL cluster in it. It has multiple roles for orchestrator and app controller. It has a VMM cluster. It also has Windows Azure Services, the currently shipping V1 version of Windows Azure Services. So this is a fairly typical service provider type deployment. Just wanted to start those 2 right at the beginning, and we'll come back to them as we go through. So that was starting a full deployment and a highly available scale-out deployment. So what is System Center? System Center is one product, but it actually consists of 7 different components. Somebody said 7. I would question whether there's 7 or 8. Service Provider Foundation is hidden in part of Orchestrator. I really think of that as a separate component, but officially there are 7 components to make up System Center 2012 today. The question was, what about Advisor? Advisor actually isn't part of System Center. Right, so it's called System Center Advisor, but it's not licensed as part of the System Center product. It used to be an SA benefit, and it's now freely available as an SA benefit. No, it's freely available for the products. If you're licensed for the product it advises about, but it's not actually part of System Center. However, each one of those 7 components consists of a number of roles, and this is by no means an exhaustive list of all of the roles that make up each one of those components. Configuration Manager, for example, has a lot more roles. These are essentially the roles that the core setup for that component will install for you. But if you dig a little deeper, each one of these roles has a set of prerequisites. And this is where it starts to get really interesting. Each one of those roles has a combination of 1 or more of these prerequisites you need to have installed first before you can actually install that role. It's a complex thing to do. The goal with PDT is to make it a single deployment. You are installing System Center, and the deployment engine itself knows about what prerequisites are needed, what the right order of installation is, how to integrate all those things together. Really make this a single product so you can take advantage of all the capabilities we deliver. Typical experience today for installing System Center. And this actually came from my boss, or my former boss, who's actually not here. But when he joined Microsoft right around the same time as I did, we didn't have System Center at the time, but we did have SMS, and he was an old Novell guy, and he tried to install SMS, and it was kind of entertaining. He sort of documented what it took him to go and do it. So first thing you do, you define your deployment. I don't care how much automation you have, nothing replaces planning. You have to define, you have to plan and define what your deployment is going to look like for your organization. Then you go and download all the bits. Or actually what you probably do is you download the bits for one component, you start to install it, and it says you're missing some prerequisite, the SQL native client or command line utility. So you go and download that. Over time, eventually, you get all the bits you need downloaded. Then you install a bunch of servers, whether they're physical servers or VMs on whatever virtualization platform. You get a bunch of server OSs installed that you're going to install System Center against. Then you create some service accounts. Then you log on to each one of those servers, probably one at a time. You install some prerequisites, or you run setup for the component, find out what prerequisites are missing, and then go and install them. Then you install SQL. Then you probably install SQL again. Once you've realized you're missing a feature for SQL, so if you're installing Operations Manager, I needed full text search. I didn't realize that. I've got to go and do it again. Or if I'm installing Service Manager, I'm probably going to go back and do SQL again because there's the whole collation requirement thing in Service Manager. But somehow or other, you get SQL installed the way you need it. Then you grant those service accounts you created permissions, so some of them need to be administrator, some don't. You figure that out, or you just make them all administrator because that's easier. Then you install a server role. Then you potentially install other server roles. So if I'm doing another management server, or if I'm doing a web console, I'm going to add an additional server role. Then I figure out how to give the admins that I want to have access to that component permissions to them because they don't necessarily automatically get them. Then I do this post-setup integration thing. And then I probably install a console because I don't run my consoles from my servers because, of course, I'm running server core, and I would never run a console from a server anyway, right? Right? Then I connect that console to the server if I can remember which server it was I installed the right component on. Then I install some agents. Finally, I get to manage something. Right? That is a fairly typical experience of installing System Center today. The goal with PDT is to simplify that so there's significantly less steps involved. There are still some of these things that you have to do. We don't, for example, assume we have any permissions to AD, so we don't assume we're going to create service accounts for you. We also don't install agents because that's way too varied in terms of where those are going to get installed. But the goal is to make it significantly less complex, much less steps to actually get to that end state of being able to manage something. What I'm going to do through the course of this presentation is talk about how we automate each one of these steps so that you understand what PDT is actually doing. So the first thing is define your deployment. This is where the first scary bit of XML comes in, and it's really very simple. In the download off the TechEd gallery, there's actually 5 files in the download. There's 3 PowerShell scripts. There's a file called workflow XML. Those 4 you should never touch. But then there's also this thing called variable XML. This is the one that defines the deployment that PDT is going to do for you. All you need to do in variable XML is specify global settings, so things such as the username and company name that you're going to use to register that software to. Define which service account is going to be used to actually do the installation. This isn't the service account for the component. This is a service account that does the work, that does the installation. What the source path is to all of the bits, we'll talk about the bits in a moment, that are actually going to get installed. And then optionally, you provide product keys. If you don't provide product keys, we do an eval installation. If you do, it does a full license installation. Then there's some settings that you have to specify for each component. Typically, it's just the service account and password. But in the sample file, the sample variable, the component section, if there's anything else that's needed, it's listed in there. You just edit it. Then you specify which servers each role is going to be installed on. If it's a database role, you have to say what the SQL instance is, and then for each one of those SQL instances, specify a couple of additional settings. That's really all you have to do. The good news is the installer itself validates everything you put in there before it actually does the deployment. So if you've got something wrong, if you've got something missing, if you've got a password wrong, a service account name wrong, it will typically block you and tell you what's wrong in that before you can continue. So you really can't get it wrong and attempt to install something from that. So here's just a really simple example. And this is something that would install just Orchestrator. So you can see here I've specified the service account and password I'm going to use to actually do the installation. I've said which service account and password I'm going to use actually for Orchestrator in the component section, which servers I'm going to install on, and this is a 3-server deployment. This has a separate database server, a separate server for Orchestrator, and then a separate server that I'm going to install my console on. I've also specified which version and admin group to use for SQL. And in this case, I've got no product keys, so this is going to do an eval installation. Okay. That's it. That's really all you have to do to define your deployment. Obviously, if more components, the more information you need to provide, but you just take that sample variable XML file, edit it for your environment, and it's going to go and validate that, and away it goes. Second thing is get all the bits. This we have our first script. This uses the downloader. So the PDT downloader is a PowerShell script that downloads everything you need. So it downloads all the System Center components. It actually downloads the eval versions of the System Center components. However, with one exception, the bits are exactly the same as licensed. DPM is the exception. I'll talk about that a little bit more later on. But it downloads all the System Center components, all the prerequisites, so the ADK, .NET 4.0 if you're installing on Windows Server 2008 R2, the SQL native client, report viewer, WSUS if you're doing configuration manager, all the prereqs. It then also downloads both versions of SQL, both 2012 and 2008 R2, and in both cases it also downloads the service pack for those. It downloads SharePoint Foundation for use with Service Manager. It doesn't currently download Windows Server 2012. The link for that is no longer public. You have to go through registration to get that now, so it actually doesn't download that one for you. It also downloads the management packs that are needed for post-setup integration, and just for convenience, the integration packs for Orchestrator. It doesn't install them, but if you're installing Orchestrator, you're going to want them, so we download them for you. Then anything that needs to be extracted, it will go and extract. If something's an ISO, it mounts it and copies all the files out. If something's a RAR file, it uses WinRAR or 7-zip in the version I'm about to release to extract those. If something's in a zip file, it extracts from that. So anything that isn't the raw source files, it extracts. Anything that needs to be run, it goes and runs for you. So ADK is about a 1.5 meg download. When you run it, it downloads about 2 gig worth of other stuff. It runs that for you ahead of time, so it's all pre-staged before you start. It also runs the Configuration Manager downloader. So you know when you're going through Config Manager setup, there's a screen that says, I'm going to download a bunch of stuff, where shall I put it? Or, I've already got it downloaded, here's where I've previously put it. This will run that for you and pre-download all those for you. The goal is, if you want to do a complete offline deployment, after you've run Downloader, you have absolutely everything you need. You do not need an internet connection. Anything that's in a self-extracting executable, it will also run that to extract that. How big is it? The download is about 15 gig. After it's finished running all the extraction, it's about 35 gig. It's a lot of stuff. It also slipstreams SP2 into SQL Server 2008 R2 for you. It does require that you run on Windows Server 2012 or Windows 8. The reason is that's the ISO mount is a new capability in Server 2012 and Windows 8. It also requires that you have WinRAR installed, and as I mentioned, the version I'm about to release in a couple of weeks' time will also use 7-zip if that's installed. 7-zip's completely free. WinRAR is actually licensed, so 7-zip's a better option. The script has one option, dash deployment only. By default, it downloads everything that all of System Center will need. If you want it to just download for the deployment that you've specified in variable XML, it'll do that with that deployment only option. And it is completely restartable. So if something fails and you restart it, it won't re-download anything it's already done. It'll pick up from wherever it failed. So let's show you what that looks like. So incidentally, here's our second deployment, and this is the highly available one. The yellow lines are servers that are waiting on some other server to finish before they can continue. Anything in white is currently installing something. Anything in yellow is waiting on some other server. If there were anything in green, it would be complete, and if it were red, it means it failed. So let's go and look at the couple of different options for the download. So pretty simple. Right now, my installer folder here, I apologize for the size of that. I already have Windows Server, as I mentioned. The download for that isn't currently working. But if I want to do everything else, anybody want to guess how many things it has to download for all of System Center? Wild guess. 90? That was a little high. It's a lot. It'll tell you in a moment. Should tell you. There it goes. 71. So what this is actually doing is going and checking everything to see whether you already have it downloaded, and then if you don't, it's going to download it for you. On this particular system, and this is a server in one of our data centers in Redmond that we're actually looking at here, it takes about 45 minutes to do the download. I suspect the server it's downloaded may be in the rack next to it, so it's a little faster than most people experience. From my home internet connection, it takes about 2-3 hours, but obviously it all depends on the speed of your connection. If I wanted to do just a deployment-only option, this is our example that we looked at earlier. So this is just Orchestrator, and in this case, I'm going to say download deployment only. And instead of 71 things, it's going to calculate what it needs, and it's just going to download 7. Right? So if you don't want everything, if you're just doing 2 or 3 components, you can make it download just what you need. It's also restartable. So my last one here, if I were to go and delete something, so let's say I downloaded everything except Silverlight. And I'm just going to have it run again. It figures out that everything it needs is already there apart from that one thing, and it's just going to go and download what's missing. So as we release new versions of this, you can run downloader again. If there's anything new it needs, it will just refresh your download share with whatever's new. Or if it stopped partway through, you can restart it. Okay, so now I've got all the bits I need. Next thing I need to do is install each server OS. This part is actually optional in PDT. We have this thing called the VM creator. It's optional because all we need is a server OSs with the right Windows Server version joined to a domain with WinRM enabled that you have admin access to. So if you want to use existing servers, if you want to use existing VM deployment capabilities to deploy those VMs, if you want to use VMs on some other platform other than Hyper-V, that's perfectly okay. We don't care. All they have to be is the right version of Windows, domain joined, WinRM enabled, that you have admin access to. However, if you want us to create them for you, VM Creator will create those VMs for you on Hyper-V. I'm not going to help you create VMs on some other platform, even though you're welcome to use them, but VM Creator will actually create them for you. This is pretty simple. All you have to do is specify how many servers you need, specify some defaults, so which Hyper-V host they're going to get installed on, what you want the name to be, and it uses a prefix, an account, so server 1, 2, 3, 4, etc. What the defaults are in terms of amount of processor, amount of memory, disks, network adapter, domain to join. You can then also specify overrides. So if you want to use specific names, if you want to use multiple Hyper-V hosts, you can override any one of those settings for any VM. And then the VM creator validates that it has all the resources it needs to be able to create those VMs. So the parent disks you specify exist, for example. The networks, the virtual networks you want to connect to exist. If those exist, it will then create the VMs for you, join them to the domain, enable WinRM, and add your installer service account as a local administrator on those. So by the time VM Creator is done, all the VMs are ready to be deployed against. This is a snippet of the variable XML that does that, and this is just saying I'm going to install 3 servers. They're going to end up being called server 11, 12, 13, except I've got an override on one of them. So my database server, I want it to have a specific name and more memory. So from this, I'll end up with 3 servers, one called SQL 01, one called server 11, one called server 12. And I don't have a live demo for this, but I do have some screenshots. This is AD that currently has no servers in it. That's just the XML file. What VM Creator does is it uses Hyper-V PowerShell. So whatever system you run it from needs to be Windows Server 2012 or Windows 8 with the PowerShell module for Hyper-V installed. It creates the VM. It attaches it to the right network. It sets the processor and memory the way you need it. It attaches the disks. And then what it actually does is it mounts the VHD or VHDX that it creates and dynamically inserts an unattended XML file, which it then edits with the domain join settings that you specified and the installer service account that you specified. So by the time this VM has actually started, it will be joined to the domain and set up exactly the way you need it. So I'll just go through and create those. And this is actually the set of VMs that have been used in my first demo there. It takes, again, it depends on how fast your Hyper-V server is, but this lot on my pair of Hyper-V servers I run against for my demos takes about 25, 30 minutes before they're all completely created and ready to install against. There's also a version of this which is going to be in the release I keep talking about in the next couple of weeks that also will create AD for you. The version that's out there right now assumes you have an existing lab or an existing production environment. AD is already there and it's just going to connect to an existing AD. However, if you want to create completely isolated lab environments, this version will do it for you, including creating AD for you. What this one does, and you see here right now I've got no VMs, what this one does is the first VM, it actually creates as a DC. And what you see here as it goes through there is not only not only is it creating the VM, it's also taking all the source that it needs for this installation and copying it into that VM. So the unattended XML file in here includes everything it needs to promote it to a DC. And because this is an isolated lab environment, I'm taking all my source files and copying in there, so by the time it's done, I've got everything I need to do the installation. It then continues to create the other VMs while the first one starts. And you see the first one is promoting itself to a domain controller. And then the other ones are right at the bottom left corner there. It's saying waiting for Active Directory. Once all the other VMs are created, it's not going to start them until AD is completely created, because it needs to join the domain as they start. So it waits for AD to finish. That machine will reboot itself and complete. And then you'll see all those other VMs start. And then the domain controller, once it's finished, will then wait for all those other VMs to be joined to the domain. Once it finds them joined to the domain, it starts the installer itself. So it's a one-pass complete lab setup, isolated lab, from nothing to having AD and all your System Center components installed. Got a lot of feedback from the last 2 or 3 times I presented this, that this is what people really want. So it'll be ready about 2 weeks from now for release to do that. And then it completes. Okay, so now I've got my VMs. Don't create the service accounts for you. You have to pre-create service accounts. I'm not assuming that you have any additional permissions to AD as part of this. That VM creator with Active Directory, that one actually does create all the accounts for you, because it knows it has access to AD because it created it. But in the regular installation, you have to create the service accounts ahead of time. So the next thing here was log on to each server. We don't do that. We're actually doing remote installations of each of these components. And this is really where the magic happens. There's a number of requirements we have for doing remote installation. First thing is I need to be able to remotely run a command line on a number of different servers. And I need to do that using credentials delegation. That means that not only do I need to execute something remotely, but the context it runs in needs to be able to execute something else remotely from it. For example, if I'm installing a management server, and the first management server for Operations Manager, for example, creates a database against some other database server, that's double hop authentication. That's what I mean by credentials delegation. There's a number of options for doing this. And this is a lot of the work we went through with Unified Installer in how to do this right. There's a number of different ways to remotely execute a process. You can use WMI to start a process, but you don't get credentials delegation that way. You can use WinRM. WinRM is our preferred method for doing this in Windows today. WinRM by default doesn't allow you to get credentials delegation. However, you can add CredSSP, which does allow you to do credentials delegation. However, this doesn't work for remote installations of System Center. The problem is actually quite bizarre. The problem is actually Windows Update. The agent, the wusa.exe, the standalone installer for Windows Update, is specifically blocked from being remotely called, right? For whatever reason, and there is a really good reason for it, but we haven't got time to get into it now. Windows Update doesn't allow you to remotely call it, right? You actually get an access denied. So why does that matter for System Center? Well, it's not only if you're installing an update, it's also if you're checking to see whether an update is needed or not. The same executable gets used and the same block actually occurs. Several of the System Center components and prerequisites for System Center components check to see whether certain updates are installed. SQL Server 2012, for example, it checks to see if a number of Windows updates are installed. .NET Framework 4.0 on Windows Server 2008 R2 checks to see if a specific update is installed. DPM checks to see if specific updates are installed. So even if they're already there, it can't check to see whether they're there, so they fail because it's trying to use the Windows Update standalone installer. So couldn't use WinRM for this purpose. PSExec, again, this is an interesting option. It actually has this PSExec on its own. It will do credentials delegation, but it still acts as a remote install, right? So Windows Update still gets blocked. It has this option /S, which says run as a system account, which doesn't get detected as a remote execution. So that would actually work, but it doesn't have credentials delegation. Plus PSExec is still detected as malware by some certain utilities, so generally good idea to avoid that. Orchestrator has this thing called run program. It's just a modified version of PSExec. It has exactly the same problems. What we did in Unified Installer was we actually used the Orchestrator runbook server. So we installed Orchestrator first, then we added a runbook server, and because it runs as a service, it's actually a local installation with a service account, and so it has permissions to do everything we need. But you get the chicken and egg problem of having to have Orchestrator there first before you can install System Center. Of course, it's part of System Center. What we actually use in PDT is Task Scheduler, and this is actually the simplest solution I could possibly imagine. What we do is we remotely create a task. We're using the COM object to remotely register a task without a trigger. Right? So it's a scheduled task with no schedule. Then we manually start that task, wait for it to complete, and once it's complete, we check to see whether it did what we asked it to do before we continue. So it is essentially our remote execution agent. This same technique is being used in a couple of other things that my team is putting out. So if anybody went to the MAT, automated, what is that? Migration Automation Toolkit? Something like that. The automation for automating VM migration from VMware to Hyper-V uses the same technique for all of its remote execution. So what we actually use is Task Scheduler. So you never have to log on to a server. Okay. We've defined our deployment, we've downloaded all our bits, we've got our VMs. What do you think we do next? Everything else. This would be a really long and boring presentation if I went through each one of those. The next thing is actually the installer. This is the core engine that does all of the work. So this is essentially a distributed deployment controller. Right? It itself knows nothing about what it's installing. It knows nothing about System Center. All it does is know how to manage sequences of tasks across multiple remote systems, including dependencies between them, knows how to reboot something when it's needed, so how to detect when something needs a reboot. And it does that based on pending file rename operations, a Windows update being installed, or a server role or feature reporting that it needs a restart, or manually saying reboot after this step, and gracefully handles cascading failures. So what on earth is cascading failure? When you're installing System Center, you've got multiple servers, and I'm concurrently doing tasks on each one of those. So if I've got, say, Orchestrator as a simple example, I've got SQL installing on one box, I've got server roles and features installing on another box, on maybe another couple of boxes. One's going to be my management server, one's going to be my runbook server. SQL and roles and features and prereqs can all be installed at the same time. So PDT installs all of those concurrently. However, when the prereqs on the management server are finished installing, the next thing it needs to do is install the management server. But it can't do that until the SQL server is installed. So that's the dependency part. It waits at that point until the box running SQL says, I've completed installing SQL. If SQL fails, that's a cascading failure, because it's not only a failure on the server where SQL failed, it's a failure of a dependency for the server where the management server is going to get installed. So that is what I mean by cascading failures, and PDT knows how to treat those. Essentially what it doesn't roll back anything other than the individual failed installation. It will just say, the server where something failed, tell you what it failed to install, and anything that was dependent on that, it will fail at that point and not try and do anything else further on that server. It actually makes the entire process restartable as well, which is very nice. There's a number of phases that it goes through on each server. First one is if there's any service accounts that need to be added as an administrator, it'll add those. If there are roles and features that need to be installed, so IIS, for example, .NET Framework, it'll install those. SQL clusters, it actually does with dependencies between them. So if you've got multiple nodes in a cluster, they have to be installed in a certain order. It will install that cluster with dependencies between the nodes in that cluster. Then it'll install standalone SQL. Then it installs any prerequisites that may be needed. And then, with all of the cross-server dependencies, it installs any roles and post-setup integration and some light configuration. But that's all the installer knows how to do, is how to do all those things. It knows absolutely nothing about System Center itself. All of the knowledge in PDT comes from this giant XML file called Workflow XML. This is one that you don't need to know anything about. A lot of people have got very curious and started taking it apart and doing some interesting things with it, but you don't need to know anything about it. But this is everything that we know about how to deploy System Center. So this defines all the prerequisites that are needed, what prereqs are needed for a role, what that role dependencies are on other roles, what integration is needed between that role and other roles. If there are any firewall rules that need to be set for that specific role. Most System Center components set their own firewall rules. One doesn't, that's Orchestrator, and SQL also doesn't set its own firewall rules. So the workflow XML defines all of those rules, everything that needs to be set for that specific role. This also defines everything that needs to be downloaded and how everything gets installed. And there's also default settings for every installation variable as part of workflow. And I'll show you a little bit of these. This is completely extensible. So the first couple of updates that we made to PDT, there was a new version because we updated some of the scripts. The last couple of updates we've released, there's just been a new version of this workflow XML file. Right, so we found a couple of bugs. We corrected those bugs in the XML file. There was no code change to the core scripts. Added Windows Azure Services just recently. All that is a new version of the XML file. There was no need to change any of the core code or the scripts. If a partner wanted to extend this, so for example, if Veeam wanted to extend this so that their management pack automatically got installed as part of Operations Manager, they could extend the workflow XML file and it would automatically do that. So it is very extensible. It makes it pretty easy for us to maintain this. I'm going to show you a little bit about what's involved in that file. And as I said, you don't need to know any of this. A lot of people that have seen this presentation got very curious about how it actually worked, and this is really the core of it. So if I can find my mouse here. Yes, this is 11,000 something lines of XML. The core part of this defines roles. So these are all of the roles that PDT knows how to install. For each role, it defines the requirements and dependencies of that role. So if I take a simple one, the Orchestrator Management Server, this is saying for this management server on the different versions of the OS we support, so this is Windows Server 2008 R2, this is Windows Server 2012, they both need .NET Framework 3.5.1. There are some components where those server features are different between 2008 R2 and 2012, which is why those are defined that way. And then it has a dependency on the database server. So the database server needs to be complete before this role will install. It has a firewall rule down there, and then it has a reference back to an installable section, which I'll show you in just a moment. So that's a very simple role. It has very little in terms of prereqs. Let's take a slightly more complex one, the web component server in Orchestrator. And you'll see here now there are more server features, and you'll also see that these are different between the two different OS versions. So for Windows Server 2008 R2, I just need Framework 3.5.1. For 2012, I need 4.5 as well as 3.5.1. You'll also see in here that for 2008 R2, I have a prerequisite that's not a server role and feature, and that's the .NET Framework. Right? That's why the roles and features are different, because .NET 4 on Windows Server 2012 is a role and feature, on 2008 R2 is an additional installation. And again, this one has a dependency on the management server. So the management server depends on the database server, the web component server depends on the management server, and again, there's some firewall rules. That installable section refers back to here, and this is all of the things that need to be downloaded. So if I go look at, and how to execute them. So if I look at Orchestrator, where is it? Right there. This defines the Orchestrator media, and this is saying where it actually goes and downloads that media from. And then has a install section for each thing that can be installed from that media. And this says, here's the executable that needs to be run. And the rest of this are then switches that need to be provided to that executable. So these sections will either define command line switches, an INI file that needs to be created, an answer file that needs to be created. On each one of these, you'll see there's variables. So for my database name here, it's specifying a variable. That variable is replaced with whatever you specify, either the default from the workflow or an override that you put in the variable file. And the last thing to show in here is it also has conditions. So on this particular one, if I have a product key, I'm going to give it the product key command line switch. If I haven't given it a product key, it just emits that switch. So there's conditions in here as well. So it basically knows how to dynamically form the right command line to install, in this case, the orchestrator management server. One last thing before we get out of this scary file. This also defines integrations. Integrations are installed as roles. If you look in the role section, there's a role entry for each one of these integrations. The difference is you don't have to specify them. It automatically knows when to add integrations. So for example, if I'm installing Virtual Machine Manager and Operations Manager, it knows that I need to integrate those two components after they're installed. And the way it knows that is I have here a couple of sections, right? So I have an Operations Manager, Virtual Machine Manager integration section. And I also have a Virtual Machine Manager, Operations Manager integration section. What this does is basically say if these two roles are part of my installation, so if I'm installing an Ops Manager management server and a VMM management server, it knows that it needs to do this particular integration, and the target specifies which server is going to run that. So in this case, Ops Manager to VMM integration is two steps. You have to do something on the Ops Manager server first, and then do something on the VMM server. This automatically knows it needs to do all of that. You don't need to worry about it. All you know is that you've said, I'm installing Ops Manager and VMM, PDT takes care of the rest. So everything about how to install System Center is contained in that workflow file. PDT validates before it starts, right? So pre-installation validation. The first version of this we put out back in February, version 2.2. There's a reason it started at 2.2. Had no validation. It just assumed that everything in the variable XML file was correct, right? I'd been using this for internal purposes for about 1.5 years before we released it publicly, and we just got to the point where we always had the file correct, so it never failed. However, we put it out publicly, and people were obviously making even slight mistakes would cause it to fail. So what we did is add a whole lot of validation, pre-installation validation, to make sure what you've put in that file should work. It's not 100%, but most things that we know that can cause this to fail get blocked by validation. There's 3 steps to validation. Local, all that does is check the contents of the file are correct. Right, so check that every role you've specified, if that role has a dependency, you've also specified the dependency. Make sure you put an FQDN for every server. Make sure you haven't combined things that shouldn't be combined. Make sure you've specified all the variables that are required. You've specified everything that needs to be known about SQL. Anything that you're installing, make sure you have the media in the location that you specified for that. Right, so without checking any remote systems, the local validation checks the contents of that variable XML file. We then do Active Directory validation. So any service account you've checked that you've specified, we make sure the service account exists and the password that you've specified is correct. We also check other security principles. So some things you may specify groups. All we have to do is check that that principle exists. It can be a group or a user. We just have to check that it exists. We don't have to know a password for it. Obviously, if it's a group, there's no such thing as a password. Yeah. Yeah. So that's good question. The question was, can you not put the passwords in the variable file and have those specified at install time? Not yet. We've had that request a couple of times. The reason incidentally, that you'd be kidding yourself if you thought it was more secure. The reason we didn't think that was necessary for security. Yes, the passwords are in clear text, right? You already have admin access to everything it's installing against anyway. If you added the passwords after, they are still visible in clear text during installation, right? That's part of the problem with a silent install, a command line install that specifies the password on the command line. You can go and run Task Manager and see what the command line is at any time. Right? So the password is still exposed even if we didn't put it in the variable file. Having said that, we've had that request a couple of times. It's something I'm looking at. Okay. Where was I? Remote. Okay, so then we'll actually go and remotely check all the servers. So all the servers you've specified, does it exist? Do I have admin access to it? If I've specified a cluster, is the cluster already there? And all the servers that I've specified as of nodes of that cluster, are they actually nodes of the same cluster? Is WinRM enabled? Is the task scheduler enabled? Task scheduler, incidentally, some people said you can't use task scheduler because a lot of people disable that. Nobody disables that anymore. The operating system uses task scheduler for some really critical things. If back when we used to have the old AT, NT40 style task scheduler, a lot of people disabled it because there were security concerns with it. If you're still doing that, your operating system's not working right. So task scheduler, we make sure it's enabled. There's one policy that actually stops saved tasks from working. So we're actually checking that that policy isn't set. We make sure it's the right operating system version for the role that you're installing. Some roles only support Windows Server 2012. Most support 2008 R2 as well as 2012. We make sure we got file access. Minimum memory is correct just for VMM. It's the only one that has a minimum memory requirement. And if a certificate is required for installation, is that certificate there? The only one where that actually counts right now is Service Provider Foundation. But everything that we can check, we check before we do this. You can also choose to skip one or all of these, right? So if you keep running against a validation check that you're absolutely sure that it's wrong, you can tell it to skip validation. It'll just go right through. It may or may not work. I do know of some AD environments where the way we're doing the password check instantly doesn't work completely correctly. So there are valid reasons for skipping validation. So let's show you a little bit of that. Before we do, let's see where we are. Okay, so this is the first deployment. See, a bunch of stuff has gone green. That's primarily database servers that are green. There's a whole set of other things that are waiting and some things still installing. So Orchestrator is an interesting example. There's a couple of ones up here. You've got some components where certain roles are green and others are yellow, right? So that means that role in that component is waiting for some other component. That's waiting to do post-setup integration, right? It knows all the things that need to be tied to each other, so it's just waiting. Second one. Okay. This is actually pretty close. So in this case, the 3-node cluster has finished on each one of them. I've got a couple of things finishing here. So the VMM server is still running. And SQL management tools are still running. So again, everything's looking good. So let's go and look at some validation failures. So if I were to choose to do something that isn't really a good idea. So validation will block things that we absolutely know will fail and things that we generally consider a bad practice. Right, so things that we absolutely know will fail, for example, Service Manager. So here's my Operations Manager server. Somewhere, where is it? Missed it, right there. So my Operations Manager server is running on OM1, right here. And my Service Manager server is on SM1. Right. Service Manager and Operations Manager actually cannot run on the same server. Technically, it just won't install. It doesn't work. So if I were to attempt to do that, and then go and run my installer, and I'm going to tell it only to validate, it's going to block, telling me that that's an unsupported combination. So my Ops Manager server can't be combined with the Service Manager server. Okay, stops me from doing something that I know that we know won't work. change that back. Let's try a bad password. Right? So if I just change the password for my installer account, the other thing I can choose to do here is say skip validation. So in this case, that's actually an Active Directory validation that's gonna fail. So I don't want to do local validation. I just want to do AD and remote. Straight away, it tells me my service account password's wrong. Okay, those are obviously both things that absolutely will not work. Let's try something that's just generally a bad idea. Let's try let's try a dependency missing. Right, so if I delete my role for the orchestrator database server, this one is local still. Okay, told me you can't install an orchestrator management server because I'm missing the dependency of the database server. And the final one, let's just do a server that doesn't make it so a server doesn't exist. So I've specified a server that doesn't really exist. I'm going to do skip local and Active Directory. When it gets to that server, you see it's actually checking user access to that server, and because the server doesn't exist, it's failed on that. So pretty much anything that you put in there that we know can cause a failure, we're blocking on. There are a couple of things that it doesn't block on. I'll be upfront about the fact that if you specify a VMM cluster and you haven't pre-created the AD container for the distributed keys, we don't check that. There's a couple of things missing still, but for the most part, it will validate everything you need. Post-setup integration. All automatable post-setup component integration we do. There is one very notable missing integration, and that is Orchestrator. Ironically, Orchestrator is our integration product. It has these things called integration packs, but there is no automatable way to register, deploy, and configure an integration pack in Orchestrator. If you go look at various blogs, you will find some stuff that was put out there by an Orchestrator PM about a year ago before he left the company. It can be done, but it's completely unsupported, so we don't attempt to do it. There's actually one other post-setup integration thing between Operations Manager and VMM that we don't do because it takes about half an hour before you can even do it, so we don't wait that long. But everything that we know how to do that post-setup integration, it automatically goes ahead and does that. The biggest one, what I've had the most feedback on, is actually all these Service Manager ones. So if you're doing Service Manager creates a CMDB from the data that's provided or collected by various other System Center components. So primarily Configuration Manager and Operations Manager. It also collects information from Virtual Machine Manager and Orchestrator. There's a whole set of connectors that you set up in Service Manager to create that CMDB. It's quite a lot of additional work after you've installed all of these things, including Service Manager. Once PDT's finished, it just done them all for you. They're all already there. A couple other things. Admin groups. Every System Center component uses a slightly different method for how to specify who gets admin access to that component after it's installed. Service Manager is the only one that requires you to specify a group, an admin group, during setup. Orchestrator allows you to specify an admin group, but it's optional. You don't have to. If you don't specify one, it'll create a local one for you. Ops Manager, Virtual Machine Manager, and App Controller all take the members of the local administrators group and add it to its own administrators group during setup. Service Provider Foundation, DPM, both use the local administrators group, and Configuration Manager, this is actually my favorite one, Configuration Manager takes the account that's doing the installation and makes it a member of the admin group, and that's it. Right? So if you ever have an installation account you install something with and then go install the config manager console somewhere else, you don't get access to that. You have to go and add additional users to that config manager admin group before you can do that. PDT optionally allows you to specify the admin groups that should be used. Right? The only one that's required is Service Manager, because that's the only one that's actually required by the core installation itself. But you can choose to specify additional admin groups, and at the end of the installation, it will go and add those to those. So as soon as you have the console, if you're in that group, you'll be able to connect. Slight oddity, to do this with the config manager, with config manager, you have to install the console. The PowerShell for configuration manager is installed as part of the console, and it's the PowerShell that we use to add the admin group. So if you don't install a config manager console and you specify an admin group, it doesn't get added. We then also configure those consoles to connect to the correct server, right? So if so after you've installed the console, you've used PDT, you've installed the component and the console, you go and run the console. The usual experience for everything apart from Configuration Manager is it come up and say which server do you want to connect to. You have to remember which server you put that component on, go and connect to that. We automatically configure that, so the first time you run that console, it already knows what to connect to. The only one that does that by default is Configuration Manager, because it asks you during installation of the console which server you're going to connect to. And this is just a reference. I really don't expect to explain this, but this is the variables that are used for the admin group in each case. Then we have a whole set of what I consider advanced configuration. Let me just see how these things are doing here. I had one fail. Okay. There's a whole set of advanced configuration. Every setting that you would typically specify during setup can be set by PDT. We default most of them. So all you have to provide is the service account and the password in most cases. However, if you want to install to a different location other than the default location, call the database name something other than the default, you can do that. Every variable is in the workflow XML file. All you need to do is copy it to variable and change the value, and we'll use that instead. We can use existing SQL. So you don't have to install SQL with PDT. You can have an existing SQL farm and choose to use that. All you have to do is specify existing equals true on the SQL role, and it will just attempt to use it. It doesn't do any validation on that. It doesn't check to see whether it exists, you have the right permissions to it. It just attempts to use it. But if you've got existing SQL, and we found about half of our customers have a DBA group that will install SQL for them, you can use that existing SQL. It does allow you to get SQL, quote, right. Right? So default installation of SQL puts everything on the system drive. The database files, the log files, the tempdb files. It's the worst possible way to install SQL, but a default installation of SQL does that. So we do have the ability to specify all those file locations. I've got an example of that in a moment. You can also install SQL clusters. The cluster has to exist first. We don't create the cluster for you, and the reason for that is there's too many variations on the shared storage used in a cluster. The cluster and the shared storage that's going to be used has to exist first, but once that's there, we'll install a SQL cluster against that Windows cluster. Same thing with the VMM cluster. VMM is the only role that high availability means a cluster rather than multiple instances of that role. And so for VMM, we do allow you to support to install a cluster. Again, the cluster has to exist first, and the Active Directory container that the distributed keys are installed to has to exist first. We don't create that for you or validate that either. And then scale-out roles. Every other component you make highly available or scale it out by installing multiple instances of that component. So Operations Manager, you have multiple management servers. Orchestrator, you have multiple runbook servers. There's 3 different ways those things get installed. They either get installed as the first one and then additional instances of that role, or they get installed all concurrently, or they have to be installed sequentially. Operations Manager is a really good example of first, then additional. The first management server you install creates the database for you. Every other management server you install, you just tell it to use that database. Orchestrator is a good example of concurrent. So all runbook servers are equal. There is one that's the primary, but that's just the first one that gets installed, and they don't have to be installed sequentially, or one doesn't have to be installed first. You can just install them all at the same time. Data Protection Manager is a good example of sequential. Right? So if you're using multiple Data Protection Manager servers against a single instance of a database, they have, even though there's no interaction between them, they have to be installed sequentially. The reason is each installation of DPM does something to that database and then restarts the database instance. So if you're installing them all concurrently, one of them is going to work and the rest will fail because the database instance got restarted during the installation. So those have to be installed sequentially. And PDT knows about all those things and will automatically do it for you. So here's some samples of getting SQL right. In this case, this is just, as well as specifying by default the admins, it also specifies all the file locations for the databases, the log files, tempdb, and tempdb log files. So you can do a good best practice installation of SQL using PDT. You have to specify those locations. Installing a cluster, we'll install a SQL cluster either with SMB storage or with traditional cluster shared storage. This is an example of the SMB one, so I'm just saying that this database instance happens to be a cluster. Then I'm specifying the cluster down here. And the service accounts used by a cluster, a SQL cluster has to use service accounts. It can't use system accounts. And then the UNC paths to each of the locations that are going to be used for the clustered storage. This is an SMB option. You also have to specify the network, the cluster network to be used. And these are the 3 nodes that are going to get installed for that SQL cluster. Same example, except using SAN storage, shared storage, instead of SMB storage. In this case, instead of UNC paths, we just specify traditional drive letters to those. And then you also have to specify the cluster disks. These things have to match. We have no way to detect these, so you just have to get these right, and we don't validate them. A VMM cluster, instead of installing the Virtual Machine Manager management server, you're going to install a cluster active management server and a cluster passive management server. It knows the dependency between them. You also have to say what the cluster name is going to be. So in this case, those are my node names, and VMM2 is actually going to be my cluster name, my VMM server name, and the AD container for the distributed keys. And then this is just a real oddity about the VMM setup. If the cluster has static IP addresses, the cluster nodes have static IP addresses, you have to give the cluster a static IP address. You can't let it get it from DHCP. If the cluster nodes have DHCP assigned addresses, the cluster address has to come from DHCP. You can't give a static one. It took me forever to work around that one, and the VMM guys couldn't explain why they did it that way, but that's just the way it is. Then finally, scale-out roles. Each one of these roles where you may install multiples that has to be installed in a certain way, there's a primary role name and then additional ones. In the instance of Orchestrator, it's primary runbook server, then standbook run by server. That's just because that's what Orchestrator calls it. Yes, I did say these could all be installed at the same time. We specify the primary one because that's the one that will run all your runbooks by default, and you want to know which one that is. If you had them all just installed at the same time, you'd have no control over which one was actually going to take them by default. SPF, you just have additional servers. App controller, same deal, you have additional servers. Operations manager, additional management servers. Service manager, this is a slightly different instance. You can have additional management servers. These aren't scale-out roles for anything other than console connections. Right? The only thing that Service Manager uses additional management servers for is to attach additional consoles. And then DPM, you just specify as many of them as you want, and we'll install them automatically, sequentially. A couple things on troubleshooting. There's a lot of moving parts here. There's a lot of stuff happening all at the same time. And so we create and collect of log information for troubleshooting purposes. There's the installer login itself. So in the typical whatever username you're running as app data local folder, there's an installer folder that has all of the installer logs. There's a log file in there for each server that you're installing against, as well as a all-up installer log. The all-up installer log is just a combination of all the others. We log them both ways because it's easier to read them certain ways. One thing that gets added in there is every command line that PDT is running against that remote system. So if you need to troubleshoot why something failed, one thing you can do is go to the log file, get the command line, and go and remotely and locally execute that on the server and see what it comes back and tells you. Right? The full command line, it's a good reference for silent install command lines as well. The full command line is there. The passwords are blocked out in that one, but everything else in terms of the command line is in there. Then we also collect all of the logs from each one of those component setups. So the component setup log is always on the remote system that's installing against. I take those and collect them back to the system you're running the installer script from for two reasons. One, because it's easier to read them there. The other one is sometimes those logs no longer exist after something is complete. Right? So Service Manager, for example, logs to the %temp% folder, which on certain logins is going to be temp/1/2/3, etc. That temp folder, once the user that created it logs out, that temp folder is automatically deleted. Right? So in this case, the user that created it is a user in a task scheduler. Once that task completes, that's a logout, those log files get deleted. If something fails, you've got no log files. Right? It took me forever to figure it out. But if something fails, the log files have already been deleted. So we always collect them. So even though they may have been deleted from the remote system, I've got a copy of them locally. And the whole thing is restartable. If something fails, you can just wait for it to complete, figure out what went wrong, correct that, restart it, and it will just do what it failed to do before. The reason that works is everything it does, it checks to see whether it needs to do it. So you remember I said I do admins, then roles and features, then prerequisites, then SQL, actually the other way around, then roles. Every single time it goes to do something, it says, okay, I need to install, for example, .NET 4.0. It checks to see whether .NET 4.0 is already there first. If it is, it just skips that install and continues. If it isn't, it installs it and then checks to see whether it worked at the end. So if I've got a partially complete PDT run and it failed at a certain point, you just start it again. Everything that it's already done, it just skips it automatically because it checks to see whether it's already there, and because it already did it before, it's already there, so it just skips it. So you can restart. However, be careful. If you have done this and you've already put something into production, and then you come along later and say, okay, I want to add another role, I'm just going to rerun my deployment because everything that's already there, it will just skip. It may still have to do a reboot. Right? If it detects a reboot is required, and there's lots of things that happen on Windows that tell Windows that a reboot is required, that it doesn't necessarily reboot immediately. If a reboot is required, rerunning this will reboot it. So be careful about running this once something's already put in production. The other thing I'll say is some failures are just timeouts. Right? Depending on the hardware that you're running on, you may have too much stuff going on. Something may time out and fail, and you just find don't change anything, rerun it, and it'll complete the second time. I actually think that just happened on one of my demos. The systems that I'm running on, they're not really super high-powered. There's 2 Hyper-V servers. They have good storage, but not excellent storage. They each have 6-disk RAID 10 arrays in them. It's good, but it's not all SSD, so it's not crazy good. But if you run it on a laptop with a 7200 RPM disk, it's going to fail on timeouts a lot of times. I mentioned at the beginning you can deploy evaluation or license. If you give it keys, it'll license it. If you don't, it's evaluation. The one gotcha there is DPM. The media that downloader gets is eval only. So you can't give it a key and install with that DPM media license. You've got to go get your media from the volume license site. Similarly, you can't take the volume license and not give it a key and have it install eval only. So PDT is the only one you may have to switch the media. Other than that, every component you install, including DPM, can be switched from eval to license after the fact. It's different how you do it on each one of these, and the one particularly odd one is Service Manager. Service Manager, there isn't anything in-box to do it, but support services can do it for you. They have a utility that can do it. But everything, if you've installed everything in eval and you decide, okay, I want this to be my production environment now, you can actually go through and switch them all to licensed. All right, let's go. We've got 5 minutes left. Let's go and see where everything is. And I know one of them failed, so. All right, so this is the HA one. Everything completed, 52 minutes. What you'll notice is the taskbar across the bottom here, it automatically added the console icons to that. If the system that you're running an installer on is the one that the consoles are going to be installed against, it automatically adds it. So I can go and run this. This is the orchestrator one. It's not going to prompt me for which server I want to connect to because it's already configured it that way. And I'm automatically connected to that. Same thing with VMM. VMM, because this is a VMM cluster, it's going to use the cluster name, not the node names. So there you see VMM2. And it's automatically going to go connect me to that. One other example on this, the Windows Azure Services, not Windows Azure Pack, Windows Azure Services. If I can remember the right URL for this. I think that's right. It uses a self-signed certificate. Yeah, this is an interesting example because Windows Azure Services connects to SPF, and SPF connects to VMM. So there's all three things needed for a full integration in this case, but PDT just knows how to do that. And so once this comes up, the VM clouds section here, give it a second to warm up. I'm sorry? The certificates. So right now, if the component uses a self-signed certificate, it leaves it that way. If the component can use a certificate, a trusted certificate, and it's already there, it will automatically use that. Windows Azure Services, by default, just uses self-signed. It doesn't allow you to specify anything else. Right now, we're going to change that. All right, so if I come in here and go to my VM clouds and go look at providers, because I installed VMM and SPF and Windows Azure Services, it knows how to connect all three of them, and I've automatically got my cloud provider there. On the other example, which I almost don't want to show you because there's red stuff on it, okay, here's what happens when something fails. In this case, the Ops Manager reporting server failed, so everything else is there, but OM reporting failed. So this is probably a timeout. If I ran this again, it would likely complete. What I do want to show you on here is because this is the most post-setup integration, is Service Manager. So I'm just going to start the Service Manager console. And again, because all the icons automatically appeared, they weren't there before we started, it knows which Service Manager server to connect to. Once the console starts, now I have my connectors. There it is. And there, all my connectors to the other System Center components for creation of CMDB have automatically been created. So full pass, distributed installation of System Center in 1 hour on pretty decent hardware, but not super good hardware. So back to our questions. How many products are there in System Center? This is easy, right? There's one. How long does it take to deploy all of System Center? It can be done in 1 hour. Again, your hardware is the big variable there. How many screens does an installation take? One, you've still got to fill out a variable XML, right? Okay. How many post-setup integration tasks are there? Doesn't matter anymore. You don't really need to know about them. We just do them for you. Who's afraid of XML? Okay. There's less hands than there were before. Honestly, it would be really nice if there were a UI for this. I'm not a UI guy, so I'm not about to write it, but I do know of one partner that's looking at doing it, and there's some discussion we have about maybe getting it done. But the important part is the XML is not difficult. If you get it wrong, you really can't get it wrong. We'll block on almost anything you get wrong in there. It's a simple edit, and it's a massively simplified way of deploying System Center. So This is freely available in the TechEd gallery. It's documented through the Building Clouds blog. That's my team's blog. One of our primary purposes in life is to publish information about using, deploying, various things about Windows Server and System Center. If you're not following the Building Clouds blog, please go and check that out. There's a lot of really good stuff on there. There is a YouTube video. So was everyone in the keynote? I missed it because I was flying over here still. But in the keynote, the video with Brad and the Aston Martin, they do that? Yeah. The same guy that did that video did a video for me for this, but I didn't get an Aston Martin. If an hour's too long, there's a 2-minute video that shows the whole thing sped up. But there's a video on YouTube for this. It's important to note this does not replace using Configuration Manager for software distribution, using VMM for deploying VMs or services, okay? System Center has really good technology to do these things, but if you haven't got System Center, you can't do them, and so we're attempting to solve the chicken and egg problem by getting System Center deployed as easily as possible. That's PDT. I'm going to skip through these.